As climate change intensifies extreme weather, accurate forecasting is becoming more imperative than ever. The U.S. experienced 18 separate weather or climate disasters in 2022 alone, costing a total of $165 billion in damages. The disasters were also deadly, causing at least 474 direct or indirect fatalities. Tracking weather and disseminating forecasts in the U.S. has historically been the job of government agencies, like the National Oceanic and Atmospheric Administration, or NOAA. But as climate change makes weather disasters deadlier and more expensive, a new generation of private companies has cropped up to provide paying customers with hyperlocal, hyperspecific weather forecasting.
What Tomorrow is trying to do is to help customers, either countries or businesses, manage their weather-related challenges by giving them weather intelligence software. A software that tells them exactly what to do in relation to their job and their industry.
The weather forecasting services industry in the U.S. was estimated to be worth $17.4 billion in 2023.
The economic value of the forecast has always kind of far exceeded how much it costs to produce. But in an era of climate extremes, that becomes even more true, which is also why you see a lot of the impulse towards private companies to capitalize on that.
In an effort to get ahead of severe weather, NOAA is also increasingly turning to private partnerships. The organization already works with the private sector to build some of its infrastructure, like weather satellites and the supercomputers that it uses to generate forecasts. Now, NOAA is exploring buying weather data as a service. It's an effort that gained momentum in 2017, with a new law that encourages the private sector to generate weather data that the government can use to beef up its forecasts.
Society's needs for actionable and intelligible weather and environmental information is growing at such a rapid pace, with the number of billion-dollar disasters and the duration between them growing shorter for any one entity to meet alone.
Private weather companies are likely here to stay, leading some to wonder how those who can't afford their services will be affected. Weather forecasting has come a long way from its humble beginnings, when volunteers would send weather reports from all over the country by telegraph to the Smithsonian Institution in Washington, D.C., which generated a national weather map.
Meteorologists kind of improved their understanding of the atmosphere, in that sort of 100 years between those initial telegraph forecasts and World War II, beginning in the 1950s and 60s with computers and satellites up until today. You have this incredible improvement where for kind of every decade, the weather forecast improves by a day. So today's 5-day forecast is as good as the 3-day forecast was 20 years ago.
In the U.S., the National Weather Service, which is part of NOAA, releases about 1.5 million forecasts and 50,000 warnings each year as part of its mandate to protect life and property. One part of the NWS is made up of local offices, which are in charge of day-to-day weather forecasting and issuing severe weather warnings to their communities. The other part is made up of national centers, such as the National Hurricane Center, which focuses on tracking hurricanes and tropical cyclones, and the Storm Prediction Center, that focuses on tracking severe thunderstorms, tornadoes, and wildfires. Weather forecasting is an immense task that begins with collecting more than 6.3 billion observations per day of metrics like temperature, wind speed, and moisture. Over 95% of these observations come from satellites, but weather balloons, ground-based weather stations, ground-based radar, and buoys all contribute. NOAA also shares and pools observation data from foreign governments. All this information is fed into powerful supercomputers that can each crunch a quadrillion calculations per second to produce weather models, which are basically numerical representations of the atmosphere that meteorologists use to come up with forecasts.
We can forecast weather skillfully, which means that when we put out a forecast, it would be more informative than just regurgitating the average conditions on that particular day, out to about 7 to 8 days. Beyond that, it's a little more challenging. There's always going to be some imprecision and some error in our current picture of the atmosphere, and that's because we don't have an actual observation of what the atmosphere is doing at every single point on the ground or every single point in the atmosphere. So there's some assumptions being made, and those small errors grow with time as you project them out in time using things like a computer model.
In 2022, NOAA began to use 2 new supercomputers made by General Dynamics Information Technology, which the agency says will allow it to make more detailed forecasts further in advance. NOAA also makes its data sources and models available to researchers through a number of cloud providers, including Google, Microsoft, Amazon, and IBM. Despite all the high-tech sensors and supercomputers, meteorologists still play a crucial role. They generally will look at several different weather models and weigh the different outcomes against one another to come up with the most likely forecast. It's a highly collaborative process, with organizations routinely exchanging observation data with their counterparts in other parts of the world that can help to inform their own weather models.
It's part of our core mission to cooperate with other countries to bring that vital data in for our global models. Those global models turn into local forecasts.
Two of the most well-known global weather models are the Global Forecast System run by NOAA and a European model run by the European Center for Medium-Range Weather Forecasts, an organization made up of over 30 European countries. But whereas NOAA makes its weather data available for free, the ECMWF charges for some of its data. On average, the European model has produced more accurate weather forecasts than the US model, though experts point out this doesn't mean that the European model will outperform the US one on every storm. The accuracy of the two models became a huge point of contention in 2012, after the European model predicted that Hurricane Sandy would slam into the East Coast days before the US model eventually came to the same conclusion, after originally predicting that the hurricane would drift into the Atlantic.
In some cases, computer models may not necessarily capture the full intensity of the event. They may hint that a blizzard is possible, and sometimes the most intense conditions are in very localized areas. So if you think back to the pre-Christmas blizzard in Buffalo, New York in 2022, that blizzard itself was a very, very localized area, but obviously very extreme. They had about 36 hours of blizzard conditions, gusts over 70 miles per hour. And so that poses challenges in really trying to dial in the exact area that's going to get the most extreme conditions. Recent years, NOAA has provided a lot more high-resolution modeling that's really helping us dial in these types of situations.
To help foresee localized extreme weather events, NOAA is increasingly turning to the private sector.
The private sector is very adept at tailoring products and reaching niche markets that the Weather Service is not able to provide support to.
Private weather forecasting is not an entirely new concept. Companies like AccuWeather and the Weather Company, which was purchased by IBM in 2016, have been around for decades. These companies have taken the free, raw weather data from NOAA and other government agencies, repackaged it into a digestible format using their own proprietary algorithms, and distributed it to customers. Some of these private weather platforms have also collected their own supplemental weather data. But newer companies are taking private weather forecasting a step further, not only telling customers what to expect, but how to respond. Founded in 2016, Boston-based startup Tomorrow.io is in the business of offering its clients extremely detailed weather predictions and pre-storm strategy plans based on its proprietary algorithms and data. This can include things like warning a trucking company of an oncoming thunderstorm so that it can send out its fleet earlier, or helping tech companies like Uber with more accurate ETAs.
Most businesses do not have anything in place to manage weather and climate-related challenges, and if they have something, it's usually talking to a meteorologist over the phone, which is not a scalable solution.
The company says its data is more accurate than information the government can offer.
I can 100% guarantee, looking at our historical data over the last few years, that on average, our models are more accurate in between 10 to 40% than government models, not only the American models, also the European model.
Tomorrow.io's customers span a wide number of industries, from airlines for whom precise weather data can serve to help them make decisions such as whether they need to de-ice planes, to sports organizations that can use tomorrow's predictions to schedule events. Technology companies, utility companies, and government organizations are also clients. Tomorrow.io has also worked with a number of cities, including ones in New Jersey and Massachusetts, to help them prepare for incoming storms.
A state may want a very tailored, specific forecast for a road. And so because our information is public good and publicly available, the private sector can take our information and our models and our forecasts, and they can innovate on them and make pinpoint accurate forecasts. They can advise on particular road conditions, closures, what it means for local officials.
In addition to using government data, Tomorrow.io initially gathered weather information from devices like car temperature sensors, windshield wipers, and the signal strength of cellular networks, which tends to be lower when it's raining. But the company says it's moving away from this strategy in favor of space-based observations. The idea is to launch a constellation of 30 radar-equipped satellites into space by 2024 to gather weather data from every point on Earth. Last year, NOAA announced that it was partnering with Tomorrow.io to see how the company's hyperlocal satellite weather data might be used to inform NOAA's weather models. According to the agency, the agreement is exploratory and unpaid.
Radars are the most important weather sensors. They tell us where it's raining in real time, how the clouds look like, and whatnot. And right now, 5 billion people do not have radar, which means that in those places you don't even know where it's raining in real time. I'm not even talking about the forecast. You don't have flood alert, you don't have farmers insurance. The GDP is correlated to that, and it's lower.
Customers pay anywhere between $20,000 per year to millions of dollars per year for Tomorrow.io's services, according to Alphabets.
Our hypothesis at Tomorrow is that climate security is going to be very similar to cybersecurity. If you're not going to put systems in place to manage your weather and climate risks, you're going to be held accountable for not doing everything in your power to protect your assets, your customers, your top line, your bottom line.
Founded in Alameda, California about 10 years ago, Saildrone is another private company in the business of gathering and selling hard-to-obtain weather data. But unlike Tomorrow.io, Saildrone is targeting the ocean. To do this, Saildrone has a fleet of nearly 100 unmanned surface vehicles that it calls explorers. The company does not sell the vehicles themselves, but rather the data they collect. Each is outfitted with a number of different sensors that it uses to gather and transmit real-time measurements on metrics including salinity, wind speed and direction, air temperature, sea surface temperature, humidity, and barometric pressure. All variables that can be fed into weather models to improve forecasting.
In terms of the ocean's role in weather, there is a ton of interaction that happens between the surface of the ocean in terms of heat transfer and energy transfer between the ocean and the atmosphere. And that interaction is where weather systems garner a lot of their energy.
One of the most important ocean weather phenomena that Saildrone is helping forecasters track are El Niño and La Niña.
Things like El Niño, La Niña, the North Atlantic Oscillation, or NAO, longer-term patterns like that will tend to affect weather over the course of an entire season or an entire year. So for instance, you might say, in El Niño, the water temperatures in the tropical Pacific Ocean are warmer than normal. On average, you can expect wetter conditions in California and the West Coast and places like that. Doesn't mean that on a particular day that you're going to get a storm system or that a particular storm system is made possible because of El Niño. It just loads the dice towards certain outcomes in certain areas of the world.
Saildrones have also been very useful in tracking and observing hurricanes, a task that the company has undertaken in partnership with NOAA for hurricanes like Sam in 2021 and Fiona in 2022. Data gathered from Saildrones will help NOAA with one of the biggest challenges in hurricane forecasting, predicting rapid intensification, when hurricane wind speeds increase at least 35 miles per hour over a 24-hour period. In the past, human hurricane hunters and buoys gathered much of this data for NOAA. But Saildrone allows the agency to gather data from parts of the hurricane that are too dangerous for people to fly into, or areas that are not covered by their buoy system. NOAA has also used Saildrone to collect fish population data and map the ocean floor.
Nearshore surface mapping, knowing the depths of the oceans, knowing where the shelves are, helps with forecasting floods and coastal inundation. So there's some big efforts that we were looking to take part in Florida to better map the coastal areas there to help inform flood inundation and flood forecasting.
To accomplish these ocean mapping missions, Saildrone has two larger models of its vehicles that can be equipped with sonar. Like Tomorrow.io, Saildrone has customers beyond NOAA, including the U.S. Navy, Customs and Border Protection, and the U.S. Coast Guard, which are using the Saildrones for surveillance. Saildrone declined to comment on the cost of its services, but customers reportedly pay around $2,500 for a day of Saildrone data. While public-private partnerships can provide NOAA with valuable data to improve its forecasts, some worry about a future where NOAA and the public become overly dependent on private weather companies.
The advantage of privatizing it is you get all the force of private innovation, more accuracy and better decisions and better observations and better satellites and better supercomputers and all those things. What you're doing, though, is you're immediately setting up the situation where people who can pay for forecasts are at less risk or safer than people who can't pay for them. And in an era of climate extremes, when you're talking about evacuations, when you're talking about hurricanes, when you're talking about deadly snowstorms, you really have a kind of climate dystopian situation where rich people are getting out of the way of the weather way ahead of poor people.
But Alphabet says there's room for both.
If we waited for the government to develop a COVID-19 vaccine, it would have been a disaster. The government cannot, in our age, be responsible for developing innovative technology. There is a way to build innovative and great technologies and also benefit the public.
Dragon agrees that private-public partnerships will likely do more good than harm, as long as NOAA remains steadfast in its mission to serve the public good.
The private industry for the weather community is a rapidly growing market, and the taxable revenue from that industry goes right back into the economy and helps to fund public entities such as the National Weather Service. There's data sets that are absolutely essential for numerical weather prediction and getting that forecast down to the local level. That has to remain as a public good, but there's additional data that can help increase the accuracy of those models and help make the local context very granular, and that's where perhaps there's more space to explore data buys.